Okay, guys, I'm going to show you how to construct a table of values for a quadratic equation written in vertex form. All right, and we're going to be able to do this without putting it on a graph. We're not going to need to graph it. We're going to use our vertex. We're going to use our parent equation. We're going to use our table of values, and we're going to come up with 7 ordered pairs that are on each of these graphs without actually graphing it. Okay, so let's get right to it. The vertex of these graphs, we've talked about this before. Okay, your vertex is the opposite of h, comma, k. Okay, you see the negative sign that was built in there. That's something we've talked about already. So your vertex over here for this first problem, the opposite of -3, which would be 3, comma, +1. The vertex over here would be the opposite of -2, which is 2, comma, -4. Okay, everything's going to work off of that vertex, guys. So that's the most important part, that you have your vertex down. Next step here is to look at our parent equations. So my parent equation over here for the first problem is y is equal to x squared. Okay, so I got y is equal to x squared. Over here, I got y is equal to -2x squared. I have a number in the a position, so it's going to be a little bit different over here. Okay, I make myself a table of values. Okay, so over here, I'm going to go 1, 2, and 3. Right, and then I'm going to plug those numbers in to the parent equation. So for 1, it would be 1 squared, 1 to the second power, 1 times 1, that's 1. For 2, it's going to be 2 squared, 2 to the second power, 2 times 2, that's 4. For 3, 3 to the second power, 3 times 3 gives me a 9. Okay, so I have 1, 1, 2, 4, 3, 9. I'll come back and tell you how it affects that equation in a second and what's going to do to find other points. Over here, okay, x comma y. Okay, my parent equation, I forgot to write it down. I apologize. Y is equal to -2x squared. I'm still going to go 1, 2, and 3. Okay, now when I plug them in for 1, it's -2 times 1 squared, which is -2 times 1, which is -2. For 2, it's -2 times 2 squared, which is -2 times 4, which is -8. And for 3, it's -2 times 3 squared, which is -2 times 9, which is -18. So I got my values. Once you got those values, guys, you're home free. Okay, so I got 1, -2, 2, -18, 3, -18, or 2, -8, sorry. Okay, now, when I go to find the other ordered pairs, I use the values in my XY chart to do so. The X values are really easy. Okay, if you notice, your X value go 1, 2, and 3. Basically, what that means, guys, is you're going to add 1, you're going to add 2, and then you're going to add 3 off of your vertex. So 3 plus 1 would be 4. Okay, and then just go up another one and another one. So your X values are going to be 4, 5, and 6 on one side. On the other side, because remember, this is making a U. Okay, these are parabolas. These are making a U, which we said are symmetrical. So this point is going to be symmetrical with a point over here. This point is going to be symmetrical with a point over there. So when you look at your X values, on one side, you're increasing by 1. On the other side, you're going to decrease by 1. So instead of being 4, 5, 6, you're actually going to go down. It's going to be 2, 1, 0. Okay, that's what creates that symmetry. Okay, now your y coordinates, watch what I do with my y coordinates. Your first y coordinate is going up by 1. 1 plus 1 obviously makes 2. This y coordinate is symmetrical to that y coordinate, so that's also going to be a 2. These points share a y coordinate. These points also share a y coordinate. Their x coordinates are different, but their y coordinates are the same. Okay, your next y value is going to go up by 4. So I go off my vertex. 1 plus 4 is 5. That y coordinate matches this y coordinate. Your last y coordinate is going to go up by 9. So 1 plus 9 gives me a 10. This y coordinate matches that y coordinate. Okay, so I made myself a little table of values there. I got a vertex, and I got 6 ordered pairs that are going to be on this graph. Okay, over here, over to the right. Okay, again, working off my vertex. The same thing happens with your x's. I got 1, 2, and 3. So your x values are going to go up by 1. 2 plus 1 is 3. And then I'm going to go up another one, and I'm going to go up another one. It all depends on what your vertex is, but they're just going to go up by 1 on one side. And on the other side, they're going to go down by 1. So 2 minus 1 is 1, and then to 0, and then to -1. So again, to repeat that, they're going up by 1 on one side, they're going down by 1 on the other side. One set of ordered pairs is on the right-hand side of your parabola. One set of ordered pairs is on the left-hand side of your parabola. For your y's, okay, over here, your y value is going to go down by 2. -4 down 2, so -4 minus 2, that gives me -6. This would also be -6. Then I'm going to go down 8, okay? -4 down 8, -4 minus 8, that's -12. This is also going to be -12. And then last but not least, I go down 18. -4 down 18, -4 minus 18, -22 on this side, -22 on this side. Okay, so we got ourselves a nice table of values there. Oop, what's going on here? All right, we're back. Okay, so I got myself a nice table of values there for that quadratic equation. Okay, the good thing is, guys, when you make your little charts for your parent function, your x coordinates for these are going to be 1, 2, and 3, and 1, 2, and 3. So that makes it easy when you're finding your other ordered pairs. When we start talking about numbers here that have a fraction, that obviously is going to change a little bit because we're going to want to make adjustments. But for now, we're keeping the numbers nice and neat. We're staying with integers. We're staying with nice, neat numbers. So your parent equations are going to be nice and easy for you. Okay.